Welcome to today's trial. The case, whether this basketball player is actually elite or if the data being used is complete nonsense. Wait.
The court will now decide if this player is goated or if these numbers don't even qualify as evidence.
Your Honor, the numbers don't lie.
Only if the data qualifies. Proceed. First rule of this court. No cherry-picked evidence.
Your Honor, the player is shooting 100%.
From where?
Buckets, buckets, buckets.
Hold it!
You are only watching the easy shots.
That's not a random sample.
Selection bias.
Next rule. Witnesses must be independent.
I have watched 20 shots in a row.
Out of how many total shots?
Like 22?
So before we can make any legal claim out of population, you gotta first do like a little inference checklist, right? So first of all, we need it to be random. So the data must come from a simple random sample, SRS, or a randomized experiment. Why? Because this eliminates selection bias. Without randomness, we can't really generalize findings to the population, right? And then just a warning, voluntary response or convenience samples are biased and invalid. All right, number 2, we need independence. So the 10% rule. Basically what we're saying is the sample size n has to be less than or equal to 10% of the population. Why this is? It's because when sampling without replacement, we need the sample to be small enough that the probabilities don't change. This validates our standard deviation formulas. Lastly, it's normality. So for proportions, which are categorical, we need the large counts condition, which is NP is greater than or equal to 10 and N times 1 minus P is greater than or equal to 10. So this basically ensures at least 10 expected successes and 10 failures. And for means, which are quantitative, we use the CLT, central limit theorem. So N has to be greater than or equal to 30. And small note, if your population is less than 30, you must check for outliers or else your population won't be normal. And then this whole thing is invalid. Anyways, that's kind of it. Once you check all 3, you feel me, you're good to go.
Here's what happens when data points influence each other.
Those shots weren't independent anymore.
The hype contaminated data.
When one data point affects the next, your stats stop being trustworthy.
Moving on, percentages require enough evidence.
He makes 90% of his shots.
Out of how many shots?
10.
So only 9 makes?
Your stat collapses.
That percentage is fragile.
If one miss changes everything, you don't have enough data.
Final rule. Averages require protection from outliers.
The average shot distance is 25 feet.
Explain that.
Bigger samples reduce the power of weird data points.
This data fails to meet the standards of this court.
But the numbers look good.
Numbers don't become meaningful just because you wrote them down. If the data is invalid, the conclusion is guilty.